Okay, so we'll repeat this again. The concept is to, the idea is to have an understanding of where AI and ML falls in. There's been there's a lot of things happening within the AI space, and most of us are seeing all these things happening, but they are wondering, where do I start from? And I think from today's sessions, I want to try and really give you a very, very basic example that can help you to pick from where everyone else, I believe, picked from. And it's something that's going to lead your interest as you move forward. So the objective of today is for you to understand the framework within which AI is playing, in particular machine learning. So I'll walk you through a certain example and explain how the data comes in. I'll also explain the importance of the data as the main starting point of all machine learning activity. And then I'll also take you through some of the applications, and then we'll also cover at high level, how do we evaluate whatever we are doing in terms of the performance of whatever we are building. And in this case, we are building, as ML engineers, we're going to be building models. I'll also explain what a model is, what we're building. Hopefully this will then form a very good base for you to start your journey in ML. So this class is particularly for guys who have no idea what AI ML is. The first session which we did in the morning, though it was not so clear, that has warranted us to repeat this session, is to illustrate the example. So I'll quickly go through the example. And then the second session is going to be on the theory. I'll just pull some slides and walk through with you on the theory. And then the last session, I'll go through with you Jupyter notebooks and show you some of the codes, how some of the code will look like. And in subsequent sessions, then you will actually be able to start writing code and probably install a couple of tools that you'll be using. Okay, so let me take the notebook. And I believe you can see. What I did earlier on was I drew a game called DAT. DAT is a game, is a common activity. That is a common activity that is played in a lot of sports centers. And for relaxing, it's just one of those sports that you play when you're relaxing. And today, I personally I don't play that, but I pick it as a good example to illustrate, to make this illustration, and I'll come up with my own rules. So it's not the real that game. This one becomes the bullseye. So it'll allow me to quickly draw this. I don't know if you guys can see. Where's the black marker? Black marker. There you go. Okay, so let's assume that is our dartboard. That is our dartboard. That is our dartboard. So right at the center, we can assume we have 10 points. That is 10 points. And then right here, we can say it is 8 points. For instance, 8 points. And then here we have 7 points. 7 points in each of these boxes. And then here we could say even 5 points in each of these boxes here. In each of the boxes. So the game is, as a dart game, assuming you're playing the game, is You've been told the place where you're supposed to stand when you're playing this game, and you've been given 3 arrows. The small little things are they are not arrows for violence or something like that. It's just the arrow for playing that. So you've been given those 3, and the objective is for you to aim at the bullseye, and throw so that you get the mark points. So based on this is going to be how we conceptualize and explain moving forward. So you could take note of this. We have 10, 8. For the sake of simplicity and remembrance, let's make it even. So instead of 7, 10, 10, 6, 10, 6, and 4. Because I'm going to wrap this. Yeah. So the idea is the 8 of us are going to play this game, and we want to make it easier for whoever is going to be training us to use the data that they pick for us guys to build a certain model that will be able to identify which group of people have specific characteristics that can be used to train someone else with the intent of increasing the chances of hitting the bullseye. So the objective is we want to create a model that can be used to predict whether someone is likely to hit the bullseye or not. And I'm going to walk through with you, explaining how the decisions are made when you pick that model and you open it up and unpack it. Yeah. So just capture this in your mind, and then I'm going to draw now something that looks familiar, an Excel sheet with certain columns. Okay. So this forms our table. This forms our table. Oops, it's not even, cannot be seen. Okay, just pull it. This one. There we go. I should have drawn this earlier. Whoa. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. For example, now we have 8 of us. Huh? So what we are going to do, our model is to explain hit or miss, predict hit or miss. So the first thing is Ayub is given 3 sets of arrows, and I pick the first arrow and I make a shot. When I shoot, it's a miss. When I shoot, it's a miss. And then I pick the second arrow. When I shoot, it's another miss. And then the third arrow, it's a hit. Yeah. So we have Ayub, the first one. The first miss was 0.6. The second one was 0.8. And the hit was 10. Yeah? So that is Ayub's records. And if we take other records for Ayub, it would probably be things like Ayub's height, the height, yeah, the distance within which the board is right there. The board is right there. The distance within which I'm standing further away from the board, I will say distance. And then It could be like the power of my lenses. I'm putting on spectacles. So in the case that someone does not have lenses, we could give them the highest power, meaning they are their eyesight is very, very good. And then someone with spectacles, the power of their eyesight is reduced. So we can say eyesight power, and now because of the space, let's restrict it to these three what I'll call for now variables. If you don't understand what variables is, don't worry. Just take them like they are the three properties within which we are recording. Yeah. So we are recording the height, we are recording the distance, we are recording the eyesight power. So this makes sense. I can see there are people who want to join. Let me just add them. Okay. So this, in essence, makes a lot of sense because if your eyesight is poor, then you're less likely to hit the bullseye. If you stand further and further away from the dartboard, your chances of hitting the bullseye is actually reduced. Now, if you also, now this one is debatable, the height. You could be short, but now you're equally good. You could be tall, but you're very, very poor. So this one is debatable. It is something that the machine could probably tell us. Short people are most likely to hit the bullseye, or tall people are most likely to hit the bullseye. So it is very, very difficult as a human being for you to come up with that conclusion until and unless you do a scientific study. And talking about scientific studies, now the relation between this one, and this one, including this one, let's say points. These are the points you score. Yeah? These are the points that you score. So the relations between the first column, the second column, the third column, and the fourth column in determining the results on whether you hit or you miss the bullseye is really, really, it's difficult as a human being for you to know which combination of this, if also these were numbers, is a combination 6 feet, distance 3 meters, eyesight power, I don't know how they measure power, but let's say 9 to be strong and 10 to be strong, 9 to be weak. So here I get a 6. So the distance I change it to maybe 4 meters, and then my height is standard. I change the distance to 4 meters, and my eyesight is standard. So this distance I change it to 1 meter. This is standard. Eyesight here is constant, but you see we are working with only 3. There could be so many others. There could be so many others that we add as columns here that will determine the hit or miss. Okay? So here, as human beings, we can actually tell that maybe the distance contributes because I moved closer and I was able to hit. Yeah? But what we will not as human beings tell, what is the best combination of height, distance, eyesight, and points that actually contributes? Because each of these, they have to some extent contributing to this hit or miss. Yeah? To some extent it contributes. So that is going to be, assuming we have Robin, Mary, Daisy, all of us, we put our records here, and we determine hit or miss. We could even actually check, we are 8 people, each one of us, actually what you do, each one of us come up with random numbers, yeah? Random numbers, first of all come up with, you can come up with right now, so after we can build up on this case, so that at the end you actually see. Without revealing your identity, you can just come up with 10 rows, we are 8, so 10 times 8, 10 times 8 is 80. So add up, sorry, just give me a minute. I can't see. Okay, so each one of us, let's take through 10 records. In an Excel sheet, fill whatever variables or rather whatever fields you feel that are important and then send that through to me. I will compile a single Excel sheet with 80 records, and then in the next class we will actually walk through and explain further, theoretically. So if you participate in this, it will make much more sense. It doesn't have to be realistic, just come up with numbers ideally. Your height, approximate height, the distance, probably play around, and then the last column, which is hit or miss, come up with your own random guesses. This is a hit, this was a miss, this is a hit, this was a miss, and then we will build a model on top of that. So that is the objective. Now, one thing I want to reiterate is this is the starting point, the data set. Now, what happens after the data set? Now, this data set needs to be exposed to something called an algorithm. And just let's spend a few minutes there. An algorithm is basically a set of instructions or a set of technical techniques, yeah, that have been wrapped up into a library. And this algorithm is capable of, when you expose this algorithm or you expose your data into this algorithm, the algorithm will actually use its statistical techniques or mathematical formulas to derive some relationships. And those relationships will be what we're saying, what you're asking ourselves. What is the best combination of this, and this? Meaning, what is the combination of height, distance, eyesight, and points that is likely to contribute to the optimal results? And the optimal results we are looking at is a hit. So we take our data, which is this. We expose this data to an algorithm, which is already, we have several algorithms that help us to extract some of these relationships, and we will cover them in class. So we expose that data to algorithms, and then the output of that combination becomes our model. Now we use this model to make certain predictions. Now out of this data, of course there are some people who are not in this record. Yeah. So assuming this is our gym, and we've come up with a model, and now we want to sell our model to other gym instructors, so that the gym instructor can use our model that advises them. For someone, this guy, when he comes and enrolls into your gym, take these measurements, take all these variables, and then you'd recommend them, okay, you want me to train you bullseye. I think your session will be 1 day because according to the model, you're 90% there. You're 90% there. So I only need to do a small lift. But someone else comes in, and then you feed into the model all these parameters, and then you tell the guy, for your course, it will take like a month because this is where you're starting from. So that is the idea. So once we've done our model, we need some out of what I would call another set of data to be able to test. Now, speaking about testing, there are this data, we will need to split it into three. Yeah? So for the sake of this illustration, we need to split it into training data set, we need to split it into validation data set, and we need to split it into testing data set. The training data set, I think it's obvious. This is the data set that you use to train your model. This is the data set that you combine with your algorithm and you train it so that your algorithm can go and extract. Yeah, it can extract all those unique relationships and understand the data better, and through which it can make certain predictions after that understanding. Now, since we have several algorithms, you might want to do the same using several algorithms. When you do that, they'll reach a point where out of all these algorithms, which one should you pick? And now the validation test, the validation data is one that you expose and use it to determine which algorithm out of the rest should you pick, yeah, within your working area. Now the last data set, which I'm calling the test data set, this test data set, now you've already picked the algorithm that is performing better as compared to the others. You expose the test data to your algorithm. Yeah, the one that you've picked, sorry, to the model that you've already picked. And then it performs, it will give you a prediction. Yeah, so in your validation test results, you might find that in your validation, you might get your model performing 90. Yeah, the others are performing maybe 80, 70. You tried like 7 different algorithms, or 3 different algorithms. The one was 90, 80, and the other one was 70. So you pick the one that did 90, and then you expose the test data to the one that did 90. So when the one that did 90, you expose it to new test data, and it does like 85%. So that is a possibility, meaning your model, the one that you are going to take to production, or you're going to sell to that other gym instructor, is performance is at 85%. Yeah. So there are several, that 85% is called an accuracy measure. We have several accuracy measures, and these are things like they're bundled together as evaluation metrics for an algorithm. So we have several algorithms, and each of those algorithms have a certain way of measuring their, of being evaluated in terms of their performance. All these things we will cover in class. So what I say today is basically, the journey starts with what is the problem. And in this case, the problem is, it is difficult. We want our gym instructor to be very, very efficient in either enrollment of people and determining this guy only needs a week, this guy only needs 3 months, and in 3 months, this is going to be the training schedule. We will train them how to hold the arrow, we will train them. So we are bringing in efficiency where there is no efficiency, where there is 100% reliance on the decision of an individual. And a decision of an individual as the gym owner can be biased. Yeah, the gym instructor could decide for you, give me 1,000 and it will take you, say, 2 days. But the gym instructor could be wrong. After 2 days, this guy has not learned anything. Yeah, and then the guy will be like, but you told me 2,000, I paid. After 2 days, I'll be good. I'm not good. So you see, there is a problem, and people will start running away from the gym. So the first thing you need to do is identify a problem. Yeah, once we identify a problem, we need to collect the data. Yeah, once we've collected the data as what you're seeing here, we now need to go and pick certain algorithms. Now, as a machine learning engineer, you pick certain algorithms and try and expose this to your data. And now try iterating. You build a model, you expose it to the validation test, you expose it to the test, you get your results, and then if your results are optimal and you like it, you ship it to production. Now, all machine learning engineers, this is exactly what they do. It might differ 1, 2, 3, or 4, but all of them, this is exactly what they do. It looks very simple the way I've put it, because I need to squeeze this into around maybe 15 or 20 minutes. But in reality, depending on the complexity of whatever task that is ahead of you, you could take 2 weeks. You could take even a day to build a model. You could take even 3 months, depending on complexity and your level of expertise. Yeah. So moving forward, this is a high-level illustration of the task of an ML engineer. And for you to appreciate AI and its impact, I think this is normally the starting point, and the core being statistics and mathematics. Yeah, but don't be scared. Don't be scared at all. As you'll be seeing in subsequent sessions, it is doable, even with people who've never sat in a math class. It's only that the people who sat in a math class are advantageous, just like life. Life is not fair, it's not balanced, yeah? So I'm thinking, if you understand this class is for you to understand the AI picture and from where you can start. And I've illustrated to you, you can start from a simple Excel sheet. Forget about all the difficult terminologies. Your focus should be, I want to start from this, and then grow from it. You will get to that point where you're talking about deep learning. I'm so sure you've heard about deep learning, image recognition, all these tough, gisty technological terms. Don't focus on those. Just focus on how can I solve this problem. And you'll find yourself to the point where you appreciate using deep learning technologies. You shall get there. Now, after these foundations, according to what I've posted in our WhatsApp group, we are going to be project-based learning path. So you will choose and identify a project-based learning path, as I've shared in the WhatsApp group. Now, based on this project-based learning path, we will iterate now. In this case, we'll be solving a real problem based on what you've identified. Now, I will pick a specific problem, work with you guys all the way to the end and deploy it. Now, after we've done that, you will identify a similar problem outside there and start the journey. Now you will start the journey, identify the problem, pick the data, build an algorithm, build a model, and publish this model to production. So that when you're talking to someone else, someone is actually accessing your work and you can actually articulate. So that is the journey that we are starting today. And should you find it a bit heavy, you can drop off at any time. And should you find it that you're encouraged, it is free. It is at your own pace. So some of these recordings will be available on YouTube and you can access them anytime you want. And then also when I'm available during my off working hours, I can actually reach out and answer some of your questions. So this forms the first session. We'll immediately go to the second session where I'll share with you the slides. We go through the theory, and then after that theory, I'll show you the notebook, and then we'll call it a day for today. All right? See you in a few minutes. So in my sessions, I always pick people one by one, especially situations where I have small groups like this one. So at least have one or two things to say. I'll start with Robin. Before we move to the slides, are there any concepts in the previous session that you may want to either rephrase, or even if you're good, you can just comment. Robin? Okay, I'll go to Daisy.
No, I currently have no concerns. I feel like I'm flowing. I'm okay where we are.
Okay. All right, perfect. Millicent? And just to be clear, which screen are you seeing? Are you seeing the slide or you're seeing the whiteboard?
I'm seeing the slide.
Oh, okay.
Slides.
A slide on introduction to machine learning.
Okay, perfect. All right. So, Mary, do you have any feedback? Are you following? Are you lost?
I'm okay. I'm good so far.
Okay, perfect. Maingi?
I'm good also. We are flowing at the same pace. I think we can continue.
Okay, perfect. All right. I had mentioned earlier, machine learning. You look at the data, and then expose this data to an algorithm, and based on what you've exposed, you get to build a model, and based on what the model should do, it could be prediction, where it predicts the possible outcome. And our example was either a hit or a miss. All right. So there is so much with regards to that was just a simple illustration. So the theory that we are going to go through, the illustration, I believe, forms a good base within which you can understand what machine learning is. We'll go through some machine learning terms and definition. I would mention other things like design thinking and the machine learning process. What is needed for machine learning, the types of machine learning, and some of the problems that are being solved, And I will also walk you through the very, very basics in Jupyter Notebook. Yeah. So when you stay with us, it will be a very, very interesting session. If I may, machine learning is just part of AI. I know so many people normally ask, I've heard of machine learning, I've heard of AI, I've heard of deep learning, which is which, and why are all these things different and why are they important? Now, artificial intelligence, which goes by the acronym AI, think of a child. When a child is born, do you really teach them what time they should go to the toilet, or what time they should? Do you even teach them how to express themselves whenever they feel a lot of discomfort? The answer is no. Yeah. A good example would be the firstborn is born, a family of a couple comes together, they're blessed with a child, the firstborn. So the firstborn would definitely, as they grow, the mom would tell them, go talk to your dad. The dad would tell them, go talk to your mom, or get me this thing from your mom, get me this thing from your dad. There is no explicit explanation that, hey, child, I am dad, or hey, child, I am mom. If that ever happened, then okay, those are one of the rare cases. But the normal growth of a child, especially the first child in a family, it's normally you assume rather that your presence is noticed. Hey, dad is come, dad is here, or hey, mom is here. So with time, the child grows knowing that this is mom, this is dad. And that's why when there is another new person, they immediately become auntie or uncle. That is for the first child. Okay? Now, the second child comes in. Our family is born the second child. Now, the second child would listen to the first child calling somebody dad. And they will also listen to the first child calling another person mom. And the second child will follow suit. So the second child is learning by observation. And I think more often than not, you've heard this thing that children always learn from their parents. They don't ask you questions. They just look at what you do, what you say, how you say it, and they learn from you. Yeah. So if we want to relate this with machine learning, there is some intelligence that is not taught. There is some natural intelligence of children or even human beings. Even when you look at animals, there is some instincts, some level of intelligence that make them do certain things. Yeah. If they feel threatened, they take off. Now, whenever that intelligence, first of all, we need to understand that intelligence exists. Yeah. And then that intelligence, whenever we want to now, the question is then, how do we then make computers to have that level of intelligence, where it is derived internally? Like now, a human being does not make the machine make certain decisions. The machine makes decision by itself. You get? So that is a study along artificial intelligence, where you enable a machine to make decision by itself, but you give it something to learn from. So when you give the machine something to learn from, are they able to learn from it and make certain decisions? Okay? So artificial intelligence is a broader picture, where we are making that natural intelligence and exposing it to machines. And that's why it's called artificial intelligence. Yeah. So every living being has some level of intelligence, but those are natural intelligence. So whenever you're talking about artificial intelligence, it's a way of making the machines that we are building, or the computers, to have that level of intelligence. And now we cannot claim that it is natural, because it is not. When we start exposing or training the machine to make certain decisions using a certain set of information, that is called machine learning. Yeah, and it's part of artificial intelligence. So we are not explicitly instructing a machine on what needs to be done, but we are giving the machine some set of data, and then it extracts its own decisions from this data and then makes a decision. Now, I previously had given an example of the dart game. Yeah, so the machine would look at all that data and explicitly say, or rather, extracts the information hidden in that data, like what is the best combination of height, distance, the power of the light of the eyes, as well as the points, in determining whether it's a hit or it's a miss. And then the machine will now make a decision that this is the most likely combination, and if this combination is met, then it is, say, 90% likely of a hit or 30% likely of a hit. Okay? So that is machine learning. Now, deep learning, it's more still the same. You're teaching a machine to but the techniques you're using are based on a different approach. And this approach is on something called neural networks. Okay? There are several techniques that could be clustered as deep learning, but now the core of making a decision is the way neurons work in a human being. So if you have never heard about that word, let me try. I'm not a doctor, but I'll try and explain what happens at our layman's language. So what happens is, assume like, just if you have a neighbor, okay, it's not your child. Let's think of a mother punishing the child. Yeah, and one punishment would be a smack or a pinch. Yeah, so if you pinch your baby lightly, they might think that it's a joke and they might start smiling and laughing, and you're annoyed. So when you push it further, they'll stop laughing and look at you. But when you continue further, they will start screaming, yeah, because you're hurting them. And when you continue even further, they're might likely to remove their hands. Okay? How does that information get communicated to the child for the child to be able to respond the way they do? Because the first one, it's like a smile or a laughing. The second one, it's like, okay, what's going on? A pause. They're looking at you surprised. But when you push it further, like now pinching them, exerting more force, they start screaming. And when you continue, they'll probably remove their hand, and if they can run, they take off, okay? How is that communicated? Now, using neurons, you're pinching the hand of the child, yeah? This information is communicated to the brain using some technique. By the time it gets to the brain, there is a decision that needs to be made. Should I smile? Should I just look at who this person is and what he's trying to do? Should I cry or should I take off and save my life? Yeah? Those decisions are made depending on certain thresholds. Yeah? If you continue, the decision that needs to be made is, boss, toka mbio. You're about to get slippers or something, yeah? It's no longer going to be a pinch. Now the child will say, okay, now it's time to take off, yeah? But if it's just smile, then the child will be like, oh, this one is tickling me, I need to smile. There is a way that information is communicating to the brain. Now when this threshold is met, the decision is made. And when the decision is made, the child does exactly what they want to do, yeah? So deep learning is based on that kind of communication, and it's called neural networks. There are several neurons communicating with each other through what are called neurons and tendons. Yeah. So as you advance, you'll come to understand them, or one day if you stay together, we'll get to deep learning, and you'll now actually get to understand and get to see how a neuron looks like. So that information is relayed from one neuron to another, and a threshold is called. So that is the technique used in deep learning. But in all cases, they are all artificial intelligence. Intelligence of, okay, boss, ikifika hii threshold, this is what you need to do. All right. So the difference between traditional programming and machine learning, in traditional programming, you have to explicitly tell the machine what needs to be done. But in machine learning, you don't have to explicitly say, and as a matter of fact, you just expose it and the machine decides for itself. So if you look at the example that I shared previously of the bull's eye, a man and a machine would probably use the same data set to make different decisions. So that is exactly the possible outcome. A man would say that, okay, because the distance is short, this guy is most likely to hit. But the machine would probably look like, okay, the distance is short, but this guy has poor eyesight, and also he has, he's not using enough energy, and all the other parameters are varying. So this guy is most likely to miss, regardless of whether he's near, especially when he's near, as much as he or she is near the board. So both the machine and the human being make different decisions. But there is a level of efficiency in machines. That is why we are driven to help the machines to make some of these decisions, because a machine can make several decisions in seconds. A human being could take an hour. Have you ever been in a situation whereby you're faced with a certain case and you tell them, okay, give me 2 hours, I'll get back to you. Or give me a week, I'll get back to you. A machine would make that decision and give you the output. That is one of the best things why some of these learnings of human beings we need to train the machine to do it, and we optimize our operations. So basically that is what machine learning is. That was quite some mouthful. If you have any question, you could actually just interrupt. You either raise your hand or put chat. I think I'll be watching in chat and actually giving you a chance to respond. Okay, machine learning terms and definitions. Yeah. So the first definition is when you're looking at algorithm. I had explained what an algorithm is. These are statistical techniques that are normally embedded into an application program for you guys as ML engineers to do what? To build ML models. Yeah. You'll come across them in subsequent sessions, and out of the work you're doing as an ML engineer, you'll have something called a model. Okay? So there is another term that I have not mentioned before. We have predictive variables. So these predictive variables, let's start first with the definition of a variable. A variable is just, let's pick it like, for the sake of this class, let's look at it like a column name. Yeah, a column name would be in the Excel sheet that in the illustrated data, we had the column for distance, the distance this person is from the board. We had the column for measuring the eyesight, the power of the eyesight. We had the column where we recorded the points this guy is scored, depending on where the arrow fell in, the box within which the arrow fell in. So we could have so many variables. So for now, let's look at the variable being the column name, the name of the column. Now, when it is predictive variable, it means which column name do we use to make that prediction. And in this case, we want to use a certain set of columns to make the prediction on whether someone is going to hit or someone is going to miss the bullseye. So the columns that we're going to use again are the distance, the strength of the power of the eye, the points. Now those variables that we are using to make to determine the prediction you're going to make is what is called predictive variable. Okay. Now the next variable, which is the next column name, is a response variable. Response variable is what is this that we are predicting. It at times it normally goes by the name of target variable, yeah, and predictive variable at times goes by the name independent variables, yeah. So those are some of the terms that we use. There's another term that we use for training data. Training data, I explained, is the set of data that you're using to train your and build your model. Okay. Testing data is one that after you've done validation, you want to test the performance of your model. And one of the evaluation metrics that we came across, or rather that I mentioned, was accuracy. We have several evaluation metrics, and one of them is accuracy. Yeah. So for this point, at this point, let's just understand that there's actually a way of measuring the performance of the model. We've generated a model, and now we have a way of evaluating. So when you're evaluating, someone could do a model with 80% accuracy, someone else would do it with 90% accuracy, another person would do it with 70% accuracy. There are certain reasons why even the 70% could be picked as compared to 80. There are certain reasons why 80% could be picked as compared to 90. Or there are certain reasons why 90% could be picked. Now, depending on the kind of model that you're going to build, the evaluation matrix and the possible outcome of you picking that particular model, there are several reasons why you pick one and not the other. Accuracy is not the only reason for picking a model, okay, as I will explain in subsequent sessions. All right, design thinking. Now, basically this word is, all it means is, are you able to build a solution with your customers in mind? Yeah, we are moving away from building solutions to solve our own problems, or rather the problems that we think exist, and we need to now build solutions that our customers actually we are solving the problem of our customer. So there is a methodology, and one of the methodology is called design thinking methodology, and the key focus in this methodology is we are putting the customer at the core. Yeah, and there is a process to ensure that we are putting the customer at the core. Yeah, you might be thinking that, have I not been putting my customers at the core? But there are some things that differentiate design thinking methodology with previous traditional methodologies. Yeah, this is proven to be working and acceptable across, and there is so many people adopting this, and it's been proven to be effective. Now, at a bigger scope, I would summarize it into three. You need to understand, you need to explore, and you need to materialize. Understanding is where you have one-on-one sessions with your customer. You need to empathize with your customer, and you need to allow the customer to define all their problems, and then you merge these problems with your own research. And then from the research you've done, and together with the empathy of you've given the customer, you now explore. In the exploration phase, you need to ideate. Now, assuming you're a team of ML engineers, you have business guys there, you need to ideate. What if we do this, we do this? What if we change this to this? We're just exploring options, and in the process, you can come up with a prototype. And this prototype, okay, since pictures are better than words, you go back to the customer with a prototype, yeah, that could achieve part of what they expect, or just to narrate that is this exactly what you meant when you said this. Yeah. So when the customer says, oh yes, that's exactly what I meant, you go ahead and put it and develop it. And when you're developing, this is where you now materialize it. You put it to test and implement it, and then start adding features through an iteration process. So by and large, those are the three key pillars of DTM. DTM is the design thinking methodology, and the way it's being done by one organization to another is different. It could be different depending on the structure of the organization, but the core principle of DTM is put the customer at the core, and this is a framework within which it will help you ensure that you put the customer at the core. All right. Machine learning process. We have reached a point where we've seen where the problem is. We want to increase efficiency in our gym with regards to training people on how to play the dart game. Yeah, we've generated the data. Yeah, and now when you look at the screen in front of you, then the data is where now we need to clean that data. Yeah, I had made a request that at the end of this session, I would ask you guys to each come with, say, 10 or even 20 rows and the number of columns that you can think of what you feel can contribute to an outcome of someone playing dart. So you feel that the height is important, you feel that the eyesight is important, put it in an Excel sheet and put some dummy values. You don't need to measure, just put some dummy values. Once you do that, send it through to me. I'll put up a single Excel sheet, and so that all the output from each member of this class into one Excel sheet, and then we will go through this machine learning process. We will look at the data, pre-process it, prepare it, and we make it structured. Once we make it structured, we expose it to a learning algorithm. Once we expose it to a learning algorithm, we make a model that makes certain prediction. If the model is poor in performance, we repeat by either adding more columns or adding more records. So if we had say 20 times 8 people, those are 160. We could either improve the performance of our model by adding more data in terms of we add more records in the Excel sheet from 160 to say 320. We double that. And another way of optimizing the performance of our model, either adding new columns or removing columns that are useless. So these are techniques that you learn through and see how your model improves from one that is basically guesswork to one that can actually be deployed to a gym and a consultant can actually rely upon. Once we reach to that level, we can actually deploy it. And deployment could be, it can be accessed through either an Android app or a website. And people can use it. So if your target was all gym instructors who are training people how to play dart, you can tell them, hey dude, instead of struggling with guesswork, using my model, you can actually determine if this guy you need to stay with him for 1 week or you need to stay with him for 3 months, and you can actually justify it. And you can plan and make them effective. So when you deploy it through a web app, they just go and key in the details of their customer and then they're like, okay, this guy I need to stay with them for 3 months. This guy I need to stay with them for 2 months. So that is by and large, there is no standard process for machine learning, but there are some, what I've shown you here is a guideline. So it might deviate depending on the technique that you're using. It might be different when you're using, and different depending on the problem you're solving. Deep learning, image processing, speech processing, it could be different. But for start, like I said, let's start by understanding a very, very basic problem, building a model for a very, very basic problem, and then we move slowly and slowly to where we all desire to be. All right, that is the machine learning process overview. Now, our anchor should always be problem solving. Yeah. When you're doing competition, it's very, very good to compete. What competition does, it measures your technical capabilities. Yeah. Technically, how capable are you to generate a model? It's slightly different from building a solution. A solution should be pegged on the customer. So while in competition you want to be the best, so you have to complete it from start to end. In a solution, you need to see what is the pain point for the customer at that particular time. Think of it this way. You have a Ferrari, yeah? Someone else has a piki. And the customer just wants to go from Ngong Road to South Bay in like 15 minutes. You have a very, very powerful Ferrari. Who will get to Ngong Road or South Bay in 15 minutes? So the difference between solving a problem and competition should be very, very clear. Okay? There is a way of you using Nduthi and ultimately buying a Ferrari. Okay? So within your scope, if you look at the reason why I really like focusing on solving problem is you might need a lot of years of experience to build a Ferrari. But that does not mean you're not able to solve a problem even with your Ndudi. So the little concept that you learn in machine learning, there is a problem you can solve. So build that solution, solve that problem, and slowly walk your way to building a Ferrari. Don't beat your head so hard trying to get all the technical expertise to get a Ferrari, which will only be used maybe once in a year, like right now where there is no traffic and the highway is full. That's when you can optimize, you can actually get to maybe 200 kilometers per hour. But other than that, what matters, what really matters to people in Nairobi is to get from point 1 to point B within the shortest time possible. And as you put that in focus, so that is why I brought this up. It needs to be very fit. What do you want to achieve within what time? It needs to be measurable, it needs to be attainable, it needs to be relevant, and it needs to be time-based. Okay. So as you build this, your customer would see iterations that are beneficial to them. Yeah? And that's why it needs to be very clear that you ought to identify a problem and solve and work yourself to that problem solving. We need to understand the different data that exists. We need to understand the data that we are using. So depending on the problem that you're solving, I've just given you guys an example where the data is in Excel sheet and the columns forms our variables and the rows forms our records, and the rows statistically those are terms that are called observation according to statistics. So there are different forms of data available to machine learning engineers that they play around. This is now the playing field for ML engineers, okay? So as an ML engineer, you will come across complex or structured and unstructured data. Structured data is things like data that is available in Excel sheet, for example, or text. Unstructured data is say video or audio. You get. Yeah, so we need to get an understanding of what kind of data set we are working with, like for example, sound or speech processing. So, what we're going to focus on right now is going to be very basic, because within our space we still need to solve a specific problem. And the focus is going to be structured data. Okay? Once you get this data, you need to explore what are some of, like we were identifying, which are some of the variables or which are some of the column or column names that can help us in some way make an optimal output. And in this case, the output is, do we have a miss or do we have a hit? Do we have a hit or do we have a miss? So that is a possible outcome, yeah, that we are chasing. So if we had a feeling that, okay, the distance is, and then we did not have distance in our Excel sheet. So we train and then we realize later that, okay, distance is important, let's add it. We need to add the distance and generate a new model. If there is any other field that we feel that is needed, maybe a gym instructor tells us, in my years of experience, I think this is important to track. Yeah. For example, if someone is amputee, I think it's important to track. If someone is physically challenged, I think it's important because the impact is this. It's someone, for example, someone says people with who are introverts and extroverts. Introverts are more likely to get a hit as compared to extrovert. I feel that field needs to be there. So as you iterate, you add fields, and later on the gym instructor tells you, okay, you came up with eyesight, this is not important, remove it. So because of that, you will end up removing some other fields or other columns. Yeah. So you need to explore your data. What is this data that we feel is important to have, and which are those that we feel is less important to have, and try and make certain intuition, like decisions based on intuition or decision based on expertise. And that expertise is based on, let me say, domain. If you're a gym instructor, but now, or a trainer, not gym instructor. If you're a trainer, years of experience So even in ML, there is that consideration. So there is some input and feedback that comes from the domain expertise. You assess the data, and you might find that there is some relevance. I've explained this as well. And then how much data do you need? Do you need terabytes, gigabytes? Do you need 1,000 records? You make that decision, okay? Depending on the problem that you want to solve. When you're exploring, there are certain things that you'll observe. You might observe certain values that are missing, then it's important to pick out any missing values. There is a term called an outlier. This is a record that just stands out. For example, if we are taking measurements in our DAT game or our DAT model, and then the height we've been picking on in feet, and then we see a record that says 600, for instance, instead of 6 feet. That is an outlier. You'll see 5 feet, 6 feet, 7 feet, 4, 5, 6, 5. But when you see 600, okay, you'll see like, okay, did they mean 600 centimeters? Did they mean, this one sounds off. What is it? And how do you deal with that kind of outlier? Another example would be probably analyzing employee data, and there is a salary range or salary column, and you realize that most records are between 30,000 and 80,000. Yeah, 30,000 and 80,000. And then one record has 800,000. So you might feel like, okay, this might be 80,000. Someone just added a zero by mistake. Yeah, and how you handle that outlier affects the performance of your model. So all these things need to be factored in. Yeah. So slowly by slowly, we are shifting from a very basic, straightforward machine learning problem to a slightly complex, where you're starting to consider additional things as you see it in the data. So things like missing value, how do you handle them? Outliers. And then unbalanced data set, you might find that in your data set, you have a lot of misses. Like all your records, if you had 160 records, you'll find that 150 are examples of misses. Everyone is missing according to that data set. A very few are hitting the bullseye. That is pretty expected. So if 150 are missing, then 10 records are hitting the bullseye. That's an example of a data set that is not balanced. So what is the implications and impact of your balanced state of your data set to the output or the performance of your model? These also need to be considered. So we are in a more complex consideration, and this is unearthed as we explore the data. So there is exploration exercise that we need to do that would guide us to make certain decisions. So all these things we need to be alert and aware of. Okay? All right. Now in exploration, there are certain tools and techniques that we do called visualization, and when we visualize this text, it helps us derive certain meaning out of that data. I'm so sure you guys have heard of exploratory data analysis. That is exactly the exercise that normally is done to help us understand what decisions should we make. Now, it's normally a very, very important exercise. No one builds a model without doing this EDA. So when you do this EDA, there are certain tools that you choose. Yeah, there are certain graphs. So you build graphs, you build bar charts, pie charts, and each of them tell you something about your data. You'll come up with box plots, and with a little background on statistics, it can help you even do something normally called hypothesis testing. So all these things, we will cover them gradually. Wow. I think I need to take a break. I'm going to allow you guys to ask questions, and as a way, I want us to just brainstorm on what are some of the areas you personally think you can implement machine learning, having understood what it is, So we are 9 of us. I'll just go through each one of us one by one. You just say if there is any concept that you did not understand, raise it. If you understood the concept, that is also, it's good to just comment and reiterate it and put it in your own words, because when you put it in your own words, you get to understand better. And then last thing that I would want is, within your space, what are some of the areas you feel we can build ML models to do? So I'm done with the talking. I'm going to allow you guys to talk. I think 2 minutes each, and then we go to the next and final phase for today, where we won't be coding for today. I'll just walk you through a basic exploratory data analysis Jupyter notebook, and you get to see what we will cover in subsequent classes moving forward. I'll start with Daisy. Daisy, fungua roho.
Hello. Okay, so far so good. I'm following through, and I feel like nitemnisa nimeanza kuona like what is the nini ML. Like I initially sikuwa na idea. I used just to hear people saying, ML engineers, if you're doing a course in statistics, you should do ML and data science. So far so good, and I appreciate it, and I'm flowing very well. Yeah. Currently sina swali.
Okay, that's good. Do you have any example of a machine learning problem you feel we could use ML?
Currently, I'm still brainstorming.
All right, okay. I know if you give yourself, or we give ourselves 1 week before the next class, I'm so sure the next class you guys will have a lot of examples. So we'll just walk slowly by slowly, we shall get there. Thanks, David,
Sure.
for feedback. Eve, fungua roho.
Hi. Hello. Can you hear me?
Yes, go ahead.
Okay, I've been following, but I'm up and down in town.
Oh.
Yeah, but
Okay.
maybe I'll request for is that the document you are training us with? Can I have a copy?
Yes. Sure.
Up later, maybe?
Yes, you will. Yeah. I'll make
At
all the
least like
recordings
I have.
available, as well as the presentations.
So.
Okay. We are going to the next person will be Maingi Munyoki. Fungua roho.
Hello. I've learned a lot today. I've learned about the design thinking with ML. I've learned also the machine learning process overview, the objective settings, the data understanding, the building a model evaluation and predictions. I've also learned something I didn't know about the structured data and the unstructured data. And I'm looking forward to learn more.
Okay.
Thank you.
Nice. Okay. Mary.
I might not clearly I didn't get clearly the difference between machine learning and artificial intelligence, but I've been able to flow through the lesson. I've been able to pick very well on the how we need to identify a problem and then collect data, then how you'll be able to have an algorithm that you expose the data set that you need to work on so that you're able to have a model that helps address the issue you are working on.
Perfect. Perfect. Mercy Chege? Yes, Mercy? Maybe Mercy has gone for a break. Millicent?
Hello, can you hear me?
Yes, yes, go ahead. That's Mercy, yes, okay.
Yeah, this Mercy. I was saying, at first I heard about machine learning from a colleague, and after that, the talk, I really wanted to know more about it. And for now, I'll say that I'm really enjoying the lessons, and I'm really looking forward to get to know about all this machine learning and get to even maybe to become a pro in it. So far I'm flowing with the topic, and I really do appreciate it.
Good stuff. If you hang around, it's my prayer that also you get to solve. Yeah, we are all headed there, and I know we will get there. Thank you very much for your feedback. The next person, okay. The next person is Millicent. Millicent, Fungaro.
Hey, you can hear me?
Hey. Yes, now we can hear you.
Yeah, one thing I'm so grateful to be part of this great class. I really do appreciate this because it's a thing which is starting, we are new, like for me, I've learned so much today. But I wish actually we could have this 2 times a week. I've learned a lot from what machine learning is to like exploring data rather cleaning the data. Wow, I didn't even know what outliers are. Nimezijua leo. So thank you so much. I actually look forward to the next class.
Karibu sana, Millicent. We
Yeah.
shall walk this journey together and we will solve problems together.
Okay,
Okay,
thank you.
okay. Karibu sana, Millicent. Robin, you're next.
Okay, good afternoon.
Good afternoon.
Okay, so far so good. I think the session went very well. But one thing I don't think we didn't introduce ourselves.
Oh, we can do that.
I think for me, the essence of introducing ourselves in such a forum is we need to know what each one of us does, where they come from, for the purpose of trying to leverage on each other's strength. Find maybe somebody is doing statistics, is very good in statistics. They can come in handy when we're in statistics. Somebody maybe is very good in programming. They can help the rest of us. So the essence is for us to get to know each other in the class so that we can be able to support each other. There are some who are working, so they've got the real life problems that people would want to be solved. So you can just share ideas. So I think introductions maybe may come later. And also for such a forum, my belief is we need to do a lot together. We need to cooperate. We need to help each other. We need to stand by each other, move along together. It really comes in handy. From my experience in my working environment, you never achieve anything when you do it alone. But when you do it as a team, you realize in a team, there's somebody who's always better in one or two aspects. You yourself, you're better in one or two aspects. So everybody comes and brings their strengths together. They will be able, it's a win-win situation for all of you. You get to learn a lot from each other. So one of the things that maybe I may challenge the group is let's cooperate, let's ask each other questions, let's leverage on each other's strengths. So far the class has been good. It has been clearly laid out. And the most important thing is to understand just the structure and how it flows. You mentioned about something like design thinking. I've done a course in design thinking. Very interesting. It's a very interesting course. So if anyone in the group is able, you can just go to YouTube or just read more on the internet. There's so much about design thinking. You're going to enjoy it. And one of the things maybe as you are saying, one of the problem I think we can be able to solve is a supermarket staffing problem. Because at times you go to a supermarket and find the queues are so long. You've purchased your stuff and the queues are just so long. That one is, I think, is a problem whereby the management has not been able to predict the customer flow at particular times. There are times you can go to the same supermarket, you're only alone. Yes. And there are about 6-7 cashiers who are doing nothing. Yes. There are times you can go, you find that there are about 3 cashiers or 4 cashiers, but the queue is just too much. So in such a situation, I think you can come up with a model which you can even share to in these supermarkets on how they're able to predict the customer flow after studying, after just analyzing how the customers flow, get all the data, come up with a model that is going to predict, so that when they are doing their staffing in terms of cashiers and those people who help the customers and everything, at any point in time, they've got optimum. And one of the things that most people hate is waiting on queues. So if you can be able to solve that problem, you'll have assisted the supermarket to be able to manage their queues and the food flow. So that's one of the problems I think I was having in mind. Thank you.
Wow, that is a perfect example. I can tell now you guys can relate to the task ahead. We have very unique problems, and that one is sellable. All of us normally go to supermarkets and we experience this. So you can imagine if that kind of model came through from this class, and all these people in this class participated and understand. So you can imagine the impact that would have in your own personal career path, as well as in your own studies. So Robin, I really appreciate your feedback, and we'll pick it up and make sure that guys learn to build such models. And who knows, we take that to production, and each and every person participation in solving that problem will be articulated. So you can put it in your LinkedIn, and you can even have discussions whenever such opportunity comes. So I really appreciate your feedback. And for the rest, I think this is what we should be practicing. Identify problems outside there, and we use those problems to learn in such workshops, and we make sure that that problem is solved. We put it even in our website, and now you go and tell a supermarket, boss, this is what I do, and I can help you in this way. Okay? Good stuff, Robin. Timo, tuko kwako, fungua roho.
So far, so good. Hello, can you hear me?
Yes. Go ahead.
I have been flowing nicely. I like the suggestions. Just wanted to ask a clarification. What's the difference between machine learning and deep learning? Then example.
Okay. All right. So machine learning, the techniques that are used is different. Yeah. For instance, let's pick a classification problem. A classification problem is an example of what I've illustrated, where we want to determine whether someone, when they throw a dart, they will either hit or miss. Yeah? So we are either classifying this person as this person is most likely to hit, or this person is most likely to miss. Yeah, so that one is an example of classification problem. We will go through them. Yeah, and if I take that to explain the difference of how you can use classical algorithms as compared to deep learning algorithms. In classical algorithm, you'll pick a classifier. It's an algorithm, as I've explained, and it will look through the data and extract the information they want to use to make that prediction. Yeah. But when you look at the way deep learning does it, and specifically a neural network, it will be like you're creating a network of decision-making neurons. Okay. So you'll build, this is a bit complex, I'm really trying to simplify it. So think of a neuron like, we are 9 in the group right now. Think of a neuron like each one of us, for instance. So the first, in making decision, the first gate that this information comes to, it'll be the person number 1. This person number 1 is very good in identifying the impact of height with regards to determining whether this person is a hit or a miss. Okay? Yeah. So this person extracts the possibility or the features of this information, but focuses a lot on the height, and then passes the information to the next one. So the second person, number 2, might be good in checking the strength of the eyesight, and then makes a decision based on the strength of the eyesight. Ultimately, it will go up to the person number 9, a decision is made, and then it comes back, and the process is repeated. Yeah? So the way it's repeated, it's one of the techniques we will cover much later in neural networks, and we will see how information moves from one layer to another layer, and as it moves, what information is being extracted and what will be the ultimate decision. So the ultimate decision is you're looking at the same data, and then at the end, the person number 9 said, having considered the eyesight, the distance, the height, I feel this person is most likely to hit, or I feel this person is most likely to miss. So deep learning, you make decision through, or for example, I'm going to be very specific on the neural network. You build several layers, and a decision is made at the end of it. So to answer your question, the difference between machine learning and deep learning is just the technique that is being used. Yeah.
Thank you.
All right. You had another question?
Let us ask that for now.
Oh, for now, okay. Good stuff, Timo. All right. Is there anyone who has not spoken? Let me just scroll through. All right. I think everyone has had a chance. This is what I'm going to propose. We'll take another 5 minutes break, or say, 5 minutes break. When we come back, we will do what Robin has proposed. We will introduce ourselves, we just say a bit about our background and what is the passion or you have to learn AI and ML so that we can collaborate. And what we are doing is a team sport. No one can do it alone. So you guys, let's go for a break and see you in the next 5 minutes. Sawa sawa. Okay guys, could you kindly confirm if you can see my screen? So, sorry, you can see?
Yes.
Yes, I can see it.
Yes.
Okay, so what we're going to do, before we pick up, I think based on what Aswadi had said, just quickly, you could introduce yourself, your name, what you do, and what drives your passion to learn machine learning. Yeah, just quickly, and I'll just pick. I'll start with Militant. Hello. Okay, we can come back to Millicent a bit later. So Daisy. It seems guys are not back yet. They'll find us moving on. Eve, are you in? Or should we introduce ourselves at the end? Because it looks like people are not back from the break. Maingi?
Yes.
Oh, let's start with you. You could just tell us both your names, what you do, and what's your passion. What is your? Why are you interested in my ML?
My name is Dean Maingi Munyoki. I'm a student at Strathmore University, doing Bachelor of Business Information Technology. My passion for learning ML would be to build multiple predictive models, and also I would also like to learn about the neural networks. Also building machine learning algorithms. I would also like to learn about Python data collection. Basically building models to predict certain situations. For example, I'd like to build a model for predicting football outcomes in games, whereby I would collect the data of different past games and being able to predict the outcomes of a coming game.
Interesting. Very nice.
Yeah.
Okay. Thanks,
That's
Maingi.
I would like to learn.
Cool. Thank you very much. Let's pick the next person. Mary.
Mary McKenna. I'm a colleague. I work as a customer care with staff, and my interest for learning machine learning is so that I'll be able to be equipped to be able to see how to can respond maybe to certain issues that would be able to be resolved using machine learning and artificial intelligence. Thank you.
Thank you, Mary. That's good. We go to Marcy. I don't know if Marcy is back.
Yes, I'm here.
Oh, okay.
Hello, can you hear me?
Yes. Go ahead. We are just introducing ourselves. What Robin had proposed earlier. You just say your names, what you're doing, and why you want to learn machine learning.
Okay, my name's Mercy Wangari Chege. I work at customer care. Basically, I just want to learn more about machine learning, and maybe as I get to learn about, I'll be able to build a model that maybe with time I'll be able to know which area I can be able to venture into and create a model that will be able to help to predict or maybe to solve a certain problem. So for now, I'm just basically getting equipped and to learn about machine learning.
Okay, nice, Mercy.
Yes, thank you.
Millicent, I don't know if she's back.
Yeah, I'm back.
Karibu sana, Millicent. What you're doing is you're introducing ourselves, what we do,
Yeah.
as well as want to learn machine learning.
Okay, I am Millicent Willy. I'm an accountant by profession. The reason why I'm interested in hey, niko na corona. Sorry.
Katu kwako. Stay safe.
Sorry for that.
No problem.
Yeah, I want to learn about machine learning because in accounting we do a lot of budgeting and all that. So you can create or rather build models for sales forecasting, budgeting and all that. So, and also it's a new skill that I'm so interested in and I won't mind like learning a new thing. Yeah.
Yes. Sana Vincent. Sasa tuko kwa Robin.
Okay, good afternoon. Good afternoon again. My name is Robin Aswani. I work with Safaricom. I'm in basically customer experience, what we call customer experience analytics. So what we do is just get to understand the experiences that the customers go through and do a lot of analysis so that we can be able just to improve on the overall experience of the customers. I mean, my main motivation for joining this class is just to have an understanding of how to solve problems. Because I think in this world, once you solve problems, either for individuals or for businesses, you're good to go. Yeah, so I get to understand how I can solve problems that affect businesses or individuals on a day-to-day basis, and applying all what I'm going to learn here in that solving problem. Like what I'd given you as an example earlier, it's a real problem. It's a real problem that is affecting many businesses. And from the way I focus much on the customer experience, you can have, I'll just use that example. You can have a very good supermarket, very good store, has all the products, but that one point whereby people have to queue longer to pay. The last step, you're perfect all through in your supermarket, everything. You've got all the products, you've got the most friendly stuff, you've got everything. But that one last step whereby someone has to queue longer than they feel is allowed, many people will opt to go to another supermarket just because of that. So these are the things now we need to help businesses solve such problems, but ensuring the experience is a wow experience from the time the customer sets foot into your business to the time they finish their whatever business they are doing with you. So those are some of the things that I want to learn and understand and help people and businesses to solve. Thank you for that.
Thanks, Robin. Okay, we'll come back to Daisy. I don't know if she's back.
Hello, I'm back.
Okay, good.
Okay, I'm Washira Daisy, a third-year student at JQuat doing statistics. And the main reason why I joined this class is because I'm building a career in data science. So I feel like this is a gateway from my theoretical class. I feel like here is where I'll get involved in projects, real projects, learn from experts, collaborate with you guys, and also connect. Maybe in the future I'll be your colleagues.
Yes.
Thank you.
That's good. Karibu sana Daisy. Let's learn together.
Bye.
Eve. I don't know if Eve is back.
Hi guys.
Hi.
My name is Evelyn. My name is officer with the ministry. I deal with the refugees. So I decided to learn about ML out of curiosity, but I'm thinking of coming up with a predictive solution, especially with our clients. We recently introduced a queuing system, but it's not that effective. So I think with ML, I'll come up with a better solution.
Okay.
Hope I'll learn more. Yeah.
Yes, you will. Right. Is there anyone who has not introduced himself or herself?
I haven't.
Timo, yes, Timo. Okay, go ahead.
Yeah. As you heard, I'm Timo, currently a student of IT. So I'd like to study ML so that I can make models which can help me in assignments and tasks, especially which are repeated, to make work easier. Yeah.
Good stuff. All right. So I've listened to each one of you, and I strongly believe that you'll get answers in these sessions, and it will enable you to acquire the skills you need, and the motivation and the team that you need to achieve. Most of the work will depend on how far you're willing to go, your dedication, your commitment, and your openness. Just be open, don't feel shy, reach out to anyone in the group. Ukijisikia kufungua roho, you come across something on Google and you want someone to help you with that, or to listen to the thought of someone else, post it in a WhatsApp group and drive your destiny. It entirely depends on you as an individual. Don't struggle too much. This team, I believe, will help you get answers when you're stuck. You can reach out to individuals, or you can reach out to anyone in the group. All of us, I believe, our numbers are not private in the group, so you can just reach out to anyone. And I want to reiterate that the success of whatever you want to do, or wherever you want to get to, entirely depends on you. The sessions will run on a daily basis, on a weekly basis. I'll make myself available on certain hours of the day and weekends, but that's as much as I can do. But if you feel that you have not understood a concept, it is actually up to you to reach out to anyone. It is actually up to you to attend the sessions, and it's actually up to you to just be stubborn. Be stubborn and ask for help. If you keep quiet, you won't get where you want to be. All right, let's get back to now the class. And one last thing before I share the notebook. This is the last session. I know it's around lunch hour, so I'll make it like maybe in the next 10 or 15 minutes and we will be done. And I'm hoping that the next session will be more engaging. Wale wenye walikuwa wakirom Sato, Tao, I mean, those guys who are roaming around in Tao. And next weekend, I'll put a lockdown, ukae tu kwako with your laptop and the Jupyter notebook, because I would want you guys to type something. So I'm really humbled by the fact that you can actually join in even while you're doing other things. It means you are dedicated and you really want to learn something and you didn't want to miss that class. That is a very, very big step. And that is the right attitude to have if you want to learn. Okay, the screen that you're seeing in front of you is a summary of some of the possible areas we will cover as we proceed. So we have machine learning, and we're going to focus on machine learning. Once we have some comfort in machine learning, then we'll start venturing into deep learning. Yeah. So for now, when we focus on machine learning, there are several types. The first one is supervised learning. The second one is unsupervised learning. And the third one is reinforcement learning. Okay? So in the sessions that you're going to cover, the immediate sessions you're going to cover, there are two. Supervised learning and unsupervised learning. What you're going to start with is supervised learning. So if you allow me, let me just try and understand, or rather help you understand what are the differences. Now, supervised learning is when you actually know upfront what is the expected output. For instance, in our example that we had done for DAT, we knew the expected output is either a hit or a miss. So that is what you're trying to predict. We know. Yeah? So when you know the expected output, that is supervised. And the target variable is actually known. Yeah? But whenever we don't have a target variable, when we don't know the expected output, then it becomes unsupervised learning. Yeah? So, unsupervised learning, like I said, is when we do not know the anticipated outcome. An example would be, say, market segmentation or customer segmentation. So you know, when you're running either supermarket, now that Robin had mentioned about a supermarket, and I really like the project that he has proposed, and I can immediately see the learning path for that particular project. Let's speak, for example, supermarket. There are people in the supermarket, assuming you're the manager, you just want to understand what kind of customers do you have, yeah? You just want to understand what kind of customers. You don't know if this guy is a high spender, low spender. You just want to know who are these people, as in what are some of the unique properties of a customer. So in our Excel sheet, we'd have probably the days customer shopped, what they bought, how much they spent, how many times do they visit us in a week, in a month, in a year, how much are they spending, how much are we spending on them, because we might be running promotions. So we just want to understand our customers better. So you take all the purchases data you have, you put them in a box, and you run an algorithm and tell the algorithm, okay, I just want to understand how many unique groups how many unique, say 3 or 4 groups can I bucket our customers? So you have all your customers in one box, but you want to separate these customers into 3 boxes, yeah, so that you provide a more personalized service. Yeah, what would guide you to separate customers into all these 3 boxes? One of them would be the expenditure. Another one would be the number of times they visit your supermarket in a week. So that if they visit your supermarket in a week 3 times or more, they put them in one. If they visit only once, you put them in another. If they visit above 3, you put them in another. So depending on that separation, you can actually understand the kind of customers you have. So if the box 1 that people shop in your supermarket only once is the majority, then it means that in your supermarket, most likely people who are moving are the ones that are buying from you. As in, if you are located in South B, I came to South B, bought from your supermarket, and then I came back where I'm staying. Or your supermarket is next to the highway. I pass by and I buy from the supermarket and I disappear. I never come back again until the next week. So it would help you unravel what kind of things or promotions you can champion. But you see, that one is a human based separation. There could be a relation, or rather a correlation, between my expenditure, the number of times I come, the days that I come. There might be a correlation. A human being might not be able to identify that correlation and use that correlation to separate the customers into several baskets, yeah, or several boxes. So an unsupervised algorithm would be able to understand all these, what we are calling predictive variables. You put them into one, an algorithm now tells you, based on the days that this customer has come, based on the amount that he has spent, based on the goods that she has purchased, I categorize this customer as belonging to basket 1. Now that is unsupervised. Supervised, I gave an example. If you're in the banking industry, a transaction could be fraudulent or not fraudulent. So you could classify them either one of 2. If you're in a customer care industry, like I've heard most of you are in, you might want to categorize a message or an email that comes into your platform as belonging, is it a complaint, is it an inquiry, is it a billing payment, is it a recommendation? So there are several classes within which that email can belong to. So in customer service, there are reasons why you might want to categorize your messages into several categories, and it helps you make certain decisions. So that is supervised. So for reinforcement learning, I would want to use an example. For instance, the games that we play, especially the computer games that we play. If you've either played chess, or the most easier one, if you're playing a game where you're racing a game, you have 10 people on the racing lane and you're one of them. So you're competing with 9 other people. So the question would then be, how do the other 9 people know who you are? How do they know when to overtake you? Yeah? And how does the machine know when you're number 1 or number last? And how is it possible that a machine can win you and at some point you can win the machine? Yeah? So you're competing with a machine, and this time there are 9 machines. So each one of them, they're competing amongst themselves, and you're in the queue as well. Yeah? So our reinforcement learning is more like a trial and error kind of learning. Yeah? So there is something called reward and penalty. For instance, if you pass through, you're competing as you're competing, you're driving your car, you pass, let me say at the start you're number 10. You pass number 9, you get rewarded. You pass number 8, you get rewarded. You make a blunder when you're taking a U-turn, you overturn, or you miss the path, then you get penalized. And number 9 and number 10, they overtake you. You go back, you find your way back to the lane, and you start again. So when you start again, you get rewarded. So you get better as you master the lane. So the next time you're driving through that corner, you will have known. So that is how it's applicable a lot in gaming industry and building robot navigations. Yeah. So those are the three broad areas of machine learning: supervised, unsupervised, and reinforcement learning. We're going to start with supervised learning. And through the theoretical classes, I'll walk you through supervised learning. You'll get an example notebook of unsupervised learning, those two. And then immediately we go to project-based learning path, where you will understand, we could pick, depending on now your interest, we could pick one of several projects learning path. An example would be now what Aswane Robin has proposed, where can we actually predict the what's required for events to market based on the timing most people show. Yeah, so that is a type of machine learning problem. We could walk through and implement one of those issues. Yeah, one of those machine learning types, and advance it. So once we solve that problem using a machine learning algorithm, we could immediately solve it, move to a class where we understand how to solve the same problem using deep learning techniques. And then these deep learning techniques, we can now compare our first model that we didn't use deep learning technique. How does it compare to this one? Is it better? And through the process, we will have learned the very, very basic classification or machine learning techniques. And also we will have learned the machine learning problem. And at the end of the exercise, we will actually have gotten a footing where personally you can now go and rely on the theory outside there, and you can actually now chart your own destiny as an individual. Meaning you can go and attend any interview, you can identify a problem and solve it and articulate the benefit of your work to whoever you're solving it, put whatever you've done in LinkedIn, and yes, move on with your life. So by and large, this is what machine learning algorithm is revolving around. And based on what we achieve, we will now move to deep learning. Okay, so I think I'm going to go straight to the notebook and we walk through the notebook. We have like 10 minutes and we could call it a day for today. It's been a long morning, so we will continue in subsequent classes. Kidogo kidogo tu tutafika hapo. Now I'm going to share my notebook. I'm going to stop sharing this and then I share one of the notebooks that I used to do exploratory data analysis. Not for you guys to type, but for you guys to just have an idea of what happens in EDA. And this notebook does not have everything. And as you learn, as you move forward, your intuitiveness, your intuition would either add things on the EDA process or remove things in the EDA process. All right. Data analysis. I hope you guys can see it. Anyone who can confirm?
Yeah, I can see it.
Yeah, I can see it.
Perfect. So let me just make it bolder. That's better.
Yeah.
Okay, so when you're writing a Jupyter notebook, you have something called cells. So what is highlighted here is a cell, and you can add cells using this, plus you can delete them using this, and the others you can use to copy. These buttons here help you This one is to navigate either up or down. This one is when you type something on the cell and you want to see the results, you click on run. Yeah. So this notebook is just a way of exercising as a machine learning engineer, practicing. This is actually your playing field. As you get advanced, you might use other tools like Spider or other tools available through something called Anaconda. Jupyter is available through Anaconda, so you install Anaconda. So this one is an interface. Yeah. You can decide to how you document. You might want to document your thought process. It's good to document your thought process so that you can always come back and understand your line of thought. And even when you're sharing ideas with your other ML engineers or students, you get to make reference. Yeah. So basically, high-level steps for EDA, you need to import the required libraries. I'll show you. You need to load that data into a data frame. A data frame is like a storage where I had mentioned, think of it like the Excel sheet that we built on our hit or miss that game. You now want to import it into Jupyter. I will show you how to import that and load it into a data frame so that you will, moving forward, you manipulate that data from within a data frame. Once you've loaded it into a data frame, you explore and describe the data, like now checking the types of data. There are several instances where the type of data is important. For example, if you want to manipulate your data based on date, you want to visualize your data based on date, it will be necessary to ensure that your date column is actually in date data type. So there is something data type, we have several data types. We are slowly moving into a bit of complexity in terms of now you've heard about data types. Data types just differentiates or distinguishes the types of data that you're handling, or rather the type of text that is present in your data frame. So the possible types of text that is present in your data frame, it could be integer. So look at the score of given to an individual when they are throwing the dart. That is an integer. Yeah. So if we had a text like the name of that individual, that would be a different data type, and it could be character. So it is text data type. Which is also string, or it's also character, yeah, character data type. And then if you had a date, when the date that person played that game, that text is stored in a date data type, yeah. So understanding the different data types for your text is also crucial, right? So in the event that you don't need certain columns, you will need to drop them. Or if the columns are named badly in the Excel sheet, or they are mistyped, or they don't have meaning, there might be a need of renaming those columns. So if you have duplicate rows, for instance, I entered my entry more than 5, and the same entry. It's okay, I had 3 arrows, and I played 3 times. No, I played once, but the record shows that the same game appears 3 times. So I need to delete twice. There is a decision to that. There is a reason why you need to either drop those rows. Another thing is, I'd mentioned about outliers. How do you detect and remove outliers? So outlier is something that a record that really, it looks like a mistake, and if it's a mistake, should we remove it or not? Or it looks like, no, it's not a mistake, but it's weird. What is the meaning of either we remove it or retaining it? Yeah. Once we do that, we can also use EDA. We start plotting. We can plot a graph called a histogram. This is basically just a bar chart. I'll explain this further as we move. You can also plot a scatter plot. There are several plots that you can do. You can come up with heat maps. There is a reason why you need to come up with heat maps. And then you will also come up, based on your exploration, it is important for you to come up with insights, like what do you gather from this exploration exercise? What are some of the conclusions you can come up with? So by and large, that is the objective of doing an EDA, exploratory data analysis. And a simple EDA would have definition of where you're getting the data from. You describe the data, how many columns, how many rows. You can also describe the data types. And then why are you looking at this data? You describe, you put like an objective of why you're looking at the data and what is your end game. And then your workbench is where now you'll start doing your ML EDA process. Yeah. So there are certain libraries I had mentioned, and these libraries are helping us achieve specific tasks. So for example, Pandas is a library that helps you manipulate data, like now importing that data from the several data sources into your notebook. NumPy is a scientific library that helps you manipulate big data as well. It is faster processing. It helps you manipulate complex data. Seaborn is a visualization library, yeah, well, excuse me, which helps you visualize your data as you do your exploration. And then Matplotlib is also another library that also helps you to visualize. Jupyter has a way of allowing you, this is a magic sign. So this one basically enables you to view the plots that you plot using Matplotlib. And then this one is an environment setting or configuration setting for Seaborn that allows you, in this case, to enable colors. So you want to see your plots in colors. This code is how we will be uploading the dataset. So assuming this dataset, our dataset that I would request you guys to send to me so that we can compile our dataset, this is how we will import it. Yeah. And now exploring, we have several techniques. You can view the first top rows. This is how you do it. And then you view the last rows, 5 of them, and then it displays, so you can actually start checking on your Excel, but now from within Jupyter. Sample gives you random. It's neither the top nor the bottom. It samples and retrieves 5 records for you to see randomly. And then this is where now you check the data types. Yeah, when you're checking the data types, it will tell you integer. Object is like character. And then in this case, do we have a date object? No, we don't have date. So if you had a date, you'll see date time. So it's good to check. So if you have a date column that is stored as an object, you definitely know that since I will be doing manipulation using date, I need to convert this to date format. Yeah. And then dropping relevant code, there is a code for dropping. Once you know that there is a certain set of columns you don't want to use, you need to remove them from your dataset. There is a way of renaming the columns if some columns do not make sense. For example, HP, someone who's not dealing with cars will be struggling to understand what is HP. So you might want to say engine horsepower, for example, or engine cylinders. So you give it some name that makes sense to everyone. So that would be necessary. And then this one is how you explore after renaming. Yeah, makes a lot of sense. And then you check if there is any duplicate rows. If there is duplicate rows, then you drop the duplicate rows. Okay? Dropping the duplicate rows, and then check the count, missing and null values. All these are code that help you achieve specific tasks. We won't go through all of them right now, but I'm going to make this notebook available in my GitHub. You can download and just go through them ahead of the next class. Okay? We detect outliers. I've written a bit of explanation how to detect outliers, the approaches. There is a box plot there. Yeah, we will cover outliers in class. So we'll have sessions where we explore outliers, and one of the techniques of identifying outliers, how to plot, scatter plot, something like this. So this is just to introduce you to some of the things that we'll be doing, and visualization. These are basic, and with time you'll get comfortable with all this. And there is a heat map, and you'll get to understand what a heat map is and how it is why it is important. And here, based on your EDA, you do your conclusion based on your study. So at the beginning, if your study was a certain statement, that study goes to the objective. At the conclusion, you need to derive the insights as well as the conclusion. Now, after the EDA exercise and based on the conclusions that you've come up with, now we can move into starting to do ML modeling and stuff. All right? And I think that marks the end of today's session. I'm having another session today in the afternoon. I'm not so sure if I'll be able to. But I think for today morning, that is what I have for you guys. And I'm going to open it for the floor for any question, any feedback, any comments, and then we call it a day until next time. Anyone with any question?
How do we access the notes and this and EDA?
Okay. The notes, the notebook itself, as well as the class audio. The class audio will be available. I'm going to put the link on the WhatsApp group. And the notebook, I'll upload it on my GitHub, and then you guys can download it from there.
Hello.
Any other question?
Hello.
Right. I'm assuming there is no question. Thank you guys. I think I really hope it was a worthwhile session. I'll share the document and see you guys next time. Have a safe, corona-free weekend and stay safe. Cheers, guys. Bye.
Thank you.
Thank
Bye.
you. Bye.
Bye bye.
Bye.